Hi, it's Loic here at Controls NYC. Last video, I talked about my points list and ideas for the Chrysler building. Today, I'm going to talk about some of the diagrams I've made and my proposal. Let's go over what some different kinds of diagrams are. First, we have an airflow diagram. This is showing all of the components inside an AHU to show how the air is going to get from the outside to the room and back in. As you can see, air is taken in by a supply fan, where it's filtered, warmed, or cooled, then sent to a VAV box where it could be warmed if desired. What it didn't show on this diagram is the exhaust vent in the room, which will take the air into the return duct in order to be sent out. Overall, I'm pretty proud of this diagram. I know some of the symbols aren't conventional, but it took a lot of work. Either way, this shows where all the components will be in the AHU. Some airflow diagrams have points showing what kind of data a component uses, such as this one, but I didn't have enough space on mine to do that, since I wanted to label the points instead. Anyone who wants to know what kind of data is necessary can just look at the points list anyways. I modeled this diagram and the points list after a video made by MEP Academy. They have a bunch of great videos on their channel if you want to check them out, so I'll link the airflow diagram video in the description. So just again to go over this, outside air temperature is measured and is compared to the set point. There's also the airflow measuring station, which measures the outside pressure that's being sent in. This is also measured across the filter with the differential pressure. There's another mixed air temperature sensor just to measure the air temperature after the mixed air is added to it. Then we have the cold and hot water control valves just to control the temperature of the air when it's passed through the heating coils. We have a smoke alarm just to make sure there's nothing bad that's coming in from outside. We have a humidifier and dehumidifier just to keep the air within the set points for humidity. Then we have our fan that's drawing the air in and pushing it out. Then we have our supply humidity that's going to measure the air just to make sure that it's within the set points. Supply air temperature, again, just to measure that it's within the set points. And a high static switch is activated if it detects fire, and then it closes the AHU to make sure that no smoke gets in. Then we have the reheat valve going to the VAV box. That's just connected to the heating coil in case the cold air needs to be heated up again, just because that one room wanted a warmer temperature, then that can be activated. Then on the return side, we have a bunch of sensors such as the return relative humidity, the return temperature, the return smoke alarm, and the return air pressure, all just to make sure that everything inside the room is good. Even though we have sensors inside the room, just maybe doesn't hurt to have that extra layer of defense. Before we take a look at the next diagrams, I'd just like to go over a couple abbreviations I've made. There's going to be 3 parts to each abbreviation. There's going to be either CW, which stands for chilled water, HW, which stands for hot water, or B, which stands for boiler water. Next, there's going to be S and R, which is either supply or return. And then there's PS, pressure sensor, TS, temp sensor, and FM, flow meter. So each one of these is going to be a combination, and you're going to see that next to the points in the diagrams. Next up is a water flow diagram. A water flow diagram shows how the water flows in the building from the chillers to the AHUs and outdoor units. Keep in mind that even though these are called outdoor units, in my case, they're going to be inside on the Chrysler building's mechanical floor. As you can see, the chilled water leaves the chiller from the evaporator, making its way to the AHUs with the help of pumps. The reason why there's multiple pumps and chillers is to have extras in case one breaks down. Then, the warmer water comes back to the chiller. In the condenser system, the water absorbs heat and is sent to an outdoor unit where powerful fans cool down the water by blowing air over it. The cooler water is then sent back to the chiller. This diagram became way more complicated than I thought it would be at first. I ended up doing many more points, a bypass, and to be honest, I think I just grossly misunderstood how these systems work before I made this diagram. I've had to update my points list accordingly for it to make sense, but I'm still happy with the way that it's turned out. It might not be perfect, but it'll serve my purposes. If you have any questions as to how this system works, I'd recommend watching a few videos made by theengineeringmindset.com. They have articles on their website and a few great videos on YouTube, so I'll link one of their videos in the description as well. The boiler system is pretty similar, but simpler than the chiller. Really, we're just using a very similar system than the evaporator system. So water is heated, sent to the AHUs and the VAV boxes, where it radiates heat into the air, and it comes back cooler than before. It goes straight back into the boiler to be reused. Since the water doesn't have to be cooled, we only need one system connected directly to the AHUs and VAVs. However, we also need some combustion fans with VFDs and dampers to go along with them in order to get air into the boiler for it to heat the water. Again, I had to redo my entire points list for my boiler section. I think I definitely needed to spend a bit more time learning about how boiler and chiller systems work before I started to do this, but at least I was able to figure it out thanks to a lot of help from Colin. Next is a riser diagram. I struggled a bit to find a video online about these that was simple enough for me to understand, so I asked my fellow intern Gerard for help.
My name is Gerard Eastman, and I'm with Controls NYC doing BMS programming and quality assurance development. Electrical risers are vertical shafts or conduits that contain electrical wiring for both communication and power. These risers carry power and communication lines vertically to different floors of a building, hence the name riser. A riser diagram is a visual representation of where these cables are going, including the floors, devices, and the type of wiring or connections. They're meant to help you understand the wiring layout between devices or endpoints by showing which devices are on which floors. This is especially useful for skyscrapers and other big buildings where not all floors will have the same systems. Network and communication riser diagrams are especially useful for me because they show me on which networks I can discover specific devices that need to be programmed, as well as which JACE units serve which specific backnet networks.
Thanks, Gerard. So, following that explanation, I'm going to have to make a riser diagram for the Chrysler building, which is 77 stories. I think I'll just start with a few floors for now. After all, many of the floors have similar sizes and layout, with my research showing 3 main floor types. I covered sequences of operations in my last video, which is the next part in completing my proposal. It's going to be a very tedious process, but I'll do my best to get it done in time for the next video. Each piece of hardware needs its own section describing its general purpose, what it does when the system is turned off, what it controls, any alarms linked to it, and a points list of points associated with it. I've had access to a couple, which were really helpful in getting an idea of the language I'm supposed to use, as well as provide me with a few direct templates. And that just about wraps up today's video. If you have any questions, ideas, suggestions, or advice, please make sure to leave a comment. I'll link those videos I talked about in the description. Subscribe if you enjoyed, and I'll see you soon.